Good afternoon, ma'am. My name is Jadro Divindas, and I would like to discuss or share with you of what I've learned in our class. First thing first, when we speak of mathematics, it is important to know what mathematics is and why is mathematics important. Mathematics is said to be all about the incredible patterns produced by nature and of our universe. In fact, Galileo once said that the laws of nature are written in the language of mathematics. There are three similar mathematical concepts that are closely related to each other: the Fibonacci sequence, golden ratio, and the Bennett's formula. I also learned that mathematics is presented in various ways, such as patterns, shapes, music, and etc. And mathematics is important because it helps us to become a better person and how to manage our decision in our life. We are exploring mathematical language and symbol in chapter 2. In the communication process, we describe language as a required tool. First of all, everybody needs to learn the language used to interact to transfer ideas effectively from one to another. For instance, if you're a Filipino and the one you're talking with is a Japanese, you can't understand each other, right? Unless if you know the language he or she talking about, right? That's why in a communication, we must understand the language first. Mathematical ideas are often difficult to understand, not necessarily because the concepts are complicated, but because they are expressed in Japanese, which is a foreign language, and that foreign language is the language of mathematics. I have discovered that mathematical language often has a distinctive features that allows mathematicians to express their thoughts and ideas easily. I also learned the various characteristics of mathematical language, namely precise, concise, powerful, devoid of emotional content, and non-temporal. I discovered, just like any ordinary language, mathematics has also parts of speech: numbers, symbol of operation, symbol of relations, symbol of grouping, and variables. There are also terms in mathematics, such as nouns, sentence sets, synonyms, and antonyms. Also, mathematics has mathematical conventions, which are the compilation of commonly recognized facts and notation in the field of mathematics. We addressed logic in chapter 3. We discussed about who are the people who contributed on the advancement of logic, and one of them is George Boole. We also defined logic. Logic is the study of formal reasoning based on statements and proposal, or science of correct critical reasoning. It is also a belief supported by factual evidence. Logic also has a statement called logic statement. As we already defined what is logic, we must also define what is statement. A statement is a declarative sentence which has a true or false but not both. We have an example in line with this. The Typhoon Auring impacted many lives in Mindanao. First, if it's a declarative sentence, we must look at the sentence first and see if it's true or false but not both. So, since it's a factual situation, therefore we can conclude that this is a declarative sentence. Moreover, it is true because the Typhoon Auring affected many lives here in Mindanao. Because all of the requirements are satisfied, therefore this is a declarative sentence. A statement itself is a special case, and that is the open sentence. An open sentence is a declarative sentence involving one or more factors that may be true or false. It also has something called the open sentence truth set that describes as a set of all values that makes the open sentence valid. It also has a simple and compound statement, where a simple statement conveys a single idea, while the compound statement conveys two or more ideas. There are also forms of statement, namely the negation, conjunction, disjunction, conditional statement, and biconditional statement. First, we must define what is negation. Negation is a form of statement that typically negates a statement. If the statement is true, then its negation is false. On the other hand, if the statement is false, the negation is true. And the second one is the conjunction. A conjunction is a form of statement which has a connector and but. In line with that, we only use but to precede a negative statement. Then, the argument is valid if both statements are true. Otherwise, it's false. Next is the disjunction. A disjunction is a compound statement joined by two statements with or as the connector. A disjunction is false if and only if the statement is false. Otherwise, it's true. Quantifiers are often referred to as quantifiers. Terms or phrases that denote the number of items to which a statement relates. In mathematical logic, there are two kinds of quantifiers: the universal quantifiers and existential quantifiers. Existential quantifiers are used as prefixes to assert something's presence. Certain phrases or terms are for some and there exist. On the other hand, the term no, all, any, every are called universal quantifiers. Fourthly, the conditional statement. Conditional statement can be written as if P then Q, where P is referred to as the antecedent while Q is the consequent. And lastly, a biconditional statement. A biconditional statement is the combination of conditional statement and its converse, written in if and only if form. A biconditional statement is true if both conditionals are true, otherwise it's false. In chapter 4, we discussed problem solving and reasoning and presented the subject in that sense, namely the inductive reasoning, the deductive reasoning, and problem solving strategy. First, the reasoning is characterized as the drawing of inferences or a conclusion from known or assumed evidences. There are also various ways of argument: inductive reasoning and the deductive reasoning. Inductive reasoning is characterized by analyzing concrete examples and aim at forming a theory as the method of achieving a general conclusion. On the other hand, deductive reasoning attempts to evaluate an established hypothesis. Inductive reasoning switches from particular observations to a broad observation, while the other way around is the deductive reasoning. One of the established mathematicians is George Polya, who invented the process of how to solve a problem called a four-step problem-solving strategy. So, in conclusion, the topics I mentioned earlier are the topics that I've learned throughout the discussion in our class. Moving on, the topic I appreciated the most are all of the topics in chapter 4, because it clearly discussed to us why is mathematics important and how mathematics can be used in our daily necessity. For example, you can find a way to solve a certain problem-solving question, but because you know how to do math and how to apply inductive and deductive reasoning and also the problem-solving strategy of George Polya, the four-step problem-solving strategy, you can solve that particular problems easily. I appreciated it the most because it can help us in terms of trouble, and we can find ways to solve a certain problem. That's why I love the topic.